In your home right now there is a clock and there is a ruler, and you have never once confused the two. One of them measures where things are, the other measures when things happen. A meter is not a minute. A hallway is not an afternoon. Everything in your life insists that space and time are two completely separate things. But here is what your senses quietly left out. More than 100 years ago, physics discovered that space and time are not two things at all. They are a single fabric, and the line you draw between them is set by nothing more than how fast you happen to be moving. Move differently, and part of what you called time becomes space. There is no universal clock. There is no shared present moment ticking across the cosmos, and you, sitting perfectly still, are already racing through this fabric at the speed of light. So if space and time are truly one, what is the single thread that ties them together, and why can nothing in the universe ever pull them apart? Get comfortable. Hit subscribe if you're new here. Because by the end of this, the simple act of sitting still in a quiet room will never feel quite the same again. Now, let's slowly ease into this. Part 1. The two things you never question. Right now, without any effort at all, you are doing two completely different things, and you have almost certainly never thought of them as related. You're sitting somewhere in space. There is a room around you, or a car, or a patch of ground under an open sky, and it has a shape you could describe. You could measure the distance from where you are to the nearest wall. You could stand up, walk 3 steps to your left, and then walk 3 steps back, and you would end up exactly where you started. Space is forgiving in that way. It lets you move in any direction you like, and it lets you return. You own your position in it the way you own a seat you can get up from and sit back down in whenever you please. You're also moving through time. This second thing does not feel like the first thing at all. You cannot take 3 steps into next week and then step back. You cannot hold still in time the way you can hold still in a room. Time is not a place you visit. It is something that happens to you steadily, whether you want it or not, carrying you forward at a pace you can neither slow nor speed nor reverse. If space is the stage you stand on, time is the current you are helplessly drifting down, and the two could not seem more unlike each other. This is the picture almost every human being has carried for their entire life. There is space, which is here, made of directions and distances and rooms, and there is time, which is elsewhere, made of moments and clocks, and the quiet forward pressure that turns today into tomorrow. They are two separate substances. They do not touch. One is a where, the other is a when, and mixing them up sounds like a category error, like asking how many kilometers long an hour is. Tonight I want to take that picture, the one that feels more obvious than almost anything else you believe, and I want to show you that it is wrong. Not slightly wrong. Not wrong in some tiny correction that only matters near a black hole or inside a particle accelerator. I mean wrong at the root. Space and time are not two things. They are one thing seen from the inside, and the line you have drawn between them your whole life is not a real edge in the universe. It is a line you drew because of the particular way you happen to be moving, and if you moved differently, the line would fall in a different place. The strangest part is that a version of this idea can be written as a sentence so short it looks like a mistake. Space equals time. It sounds absurd. It sounds like the sort of thing you would dismiss without a second thought, because everything in your experience screams that a meter is not a minute, and a hallway is not an afternoon. And yet, by the end of the slow walk we're about to take together, that sentence is going to look less like a mistake, and more like the closest thing physics has to a confession. There will be one small correction to make to it, one quiet detail that keeps space and time from being perfectly identical, and that single detail will turn out to be the reason you have a past you remember and a future you cannot see. But we're getting ahead of ourselves. Let me be honest about why this matters, before we go any further, because I do not want you to think this is only a game played with equations. The most basic feeling you have, sitting there right now, is that the whole universe is sharing this exact moment with you. You feel that there is a single, universal now, ticking along everywhere at once. You feel that on some distant world circling some distant star, whatever is happening there is happening now, in the same present tense you're living in. That feeling is so settled in you that it barely registers as a belief. It feels like simply noticing the way things are. By the end of tonight, that universal now will be gone. Not hidden, not complicated, but gone, revealed as something that never existed in the first place. Two people moving differently do not share a present moment. There is no master clock at the center of the universe keeping everyone in step. Your now is yours alone, and the traveler drifting past you has a slightly different one, and neither of you is wrong. This is not a trick of perception or a limitation of our instruments. It is the way the universe is built, and it falls directly out of one small, stubborn fact about light that took physics almost 50 years to fully absorb. I am not going to rush you toward that fact. This is the kind of idea that only makes sense if you let it arrive slowly, one careful step at a time, so that each step feels almost obvious before we take the next one. We are going to start where everyone started, with the comfortable, sensible, 200-year-old picture of a universe where space and time mind their own business and never interfere with each other. We are going to see exactly how good that picture was, because it was very good, good enough to run the world for 2 centuries and put spacecraft on other planets. And then we are going to watch it break, not because it was stupid, but because the universe turned out to be quietly stranger than the people who built it could have guessed. For now, I just want you to sit with the ordinary version of things one last time, the way you have always understood it, because you will not be able to return to it afterward. Notice the space around you, the room with its measurable walls, the directions you could walk and come back from. Notice the time you're moving through, the steady current you cannot step out of. Feel how completely different they seem. Feel how certain you are that they have nothing to do with each other. Hold on to that certainty for just a little longer. It is about to become the most interesting thing you have ever been wrong about. Because the truth is that you have never once, in your entire life, moved through space without also moving through time, and you have never spent a single second moving through time without that motion being tangled up at the level of the universe's own architecture, with your motion through space. The two have always been one. You just could not feel the seam, and the reason you could not feel it is the same reason a fish cannot feel water, or a person standing on a spinning planet cannot feel the spin. The unity of space and time is not hidden in some faraway corner of the cosmos. It is the floor you are standing on. It is so close, so constant, so much a part of every moment you have ever lived that it became invisible. Tonight we're going to make it visible, gently, and once you have seen it, the simple act of sitting still in a quiet room is never going to look quite the same. Let me show you how sure we used to be that these two things could never meet. Part 2. The Two Great Stages. The idea that space and time are separate was not a careless assumption. It was one of the most successful ideas in the history of human thought, and it was written down, in its clearest form, by Isaac Newton in the year 1687, in the book that essentially founded modern physics. Newton opened that work by laying out 2 great stages on which everything else would happen. The first stage was space. He described it as absolute, meaning it existed on its own, a fixed and infinite hall that was simply there, everywhere, always, whether or not anything was in it. Think of it as an enormous, motionless room with no walls, stretching out forever in every direction. Objects could sit in this room, or move across it, but the room itself never moved, never stretched, never cared what was inside it. It was the changeless container of all things, and every position in it was a definite place that you could, in principle, point to. The second stage was time. Newton described it too as absolute, and he chose his words with great care. Absolute time, he wrote, flows equably, of itself, without relation to anything external. What he meant was that time was a single universal clock, hanging outside the universe, ticking at exactly the same rate for everyone and everything, everywhere, forever. 1 second here was the same as 1 second on the far side of the galaxy. The clock did not care whether you were moving or standing still, whether you were on a mountain or at the bottom of the sea. It ticked, and its ticking was the same for all. There was one now, and it swept across the entire cosmos in perfect unison, so that the whole universe shared a single present moment together. These 2 stages were completely independent of each other. Space held the objects, time carried them forward. Neither one had any effect on the other. You could change where you were without changing when you were, and the passage of time went on identically no matter how you moved through space. A clock in your pocket kept the same time whether you sat in a chair, or ran a race, or flew in the fastest vehicle ever built. That was simply obvious. Everyone knew it. Everyone had always known it. And here is the thing I need you to understand, because it is easy, from where we stand now, to look back and feel superior to people who believed this. Do not. This picture was not a failure of imagination. It was a triumph. It worked. It worked almost unbelievably well, for an almost unbelievably long time. With Newton's separate space and separate time, and the law of gravity built on top of them, humanity could predict the motion of the planets with a precision that had never existed before. Astronomers could calculate exactly when an eclipse would darken the sun, decades ahead, down to the minute, and then watch it happen on schedule. They could track a comet as it swung out past the edge of the known solar system and vanished into the dark, and they could say, with confidence, the year it would return, and it would return. In the middle of the 1800s, astronomers noticed that the planet Uranus was not moving quite the way it should, and using nothing but Newton's separate space and universal time, they calculated that there had to be another unseen planet tugging on it, predicted exactly where in the sky to look, pointed a telescope at that spot, and found Neptune, almost precisely where the mathematics said it would be. That is the kind of theory this was. It was not a guess. It was a machine for predicting the future of the heavens, and for 2 centuries it did not put a foot wrong that anyone could measure. When a picture of the world works that well, for that long, it stops feeling like a theory at all. It becomes simply the truth. The separation of space and time was not something physicists argued about. It was the solid, unquestioned ground beneath everything else they argued about. You can feel why. Everything in ordinary life agrees with it. When you walk across a room, the clock on the wall does not change its pace to match your steps. When you drive down a road, your watch keeps time exactly as it did when you were parked. Add up speeds, and they behave themselves. If you walk at 5 kilometers an hour down the aisle of a train that is moving at 100 kilometers an hour, then to someone standing beside the tracks you're moving at 105 kilometers an hour, plain and simple, just by adding the 2 numbers together. Speeds add, times agree, space stays put. The 2 stages never interfere. Every single experience you have ever had confirms it. Galileo himself had captured the spirit of this 2 centuries before Newton, with an image worth keeping. Picture yourself, he said, in the sealed cabin below the deck of a smoothly sailing ship with no windows, watching flies move through the air and drops fall from a bottle into a bowl below. Everything inside behaves exactly as it would on dry land. The flies do not get swept to the back of the cabin. The drops fall straight down. Nothing inside the cabin reveals whether the ship is tied up at harbour or gliding across a calm sea at speed, and here is the part that matters for us. No matter how fast the ship sails, the drops still take the same amount of time to fall, and the clock on the cabin wall keeps perfect ordinary time. Motion changed where you were, smoothly and endlessly, but it never once touched when you were. Space was involved in the sailing. Time floated serenely above it all, untouched. The same for the sailor and for the person on the shore. For anyone who had absorbed that picture, and every educated person had, the idea that going fast could bend time itself would have sounded not merely wrong, but almost meaningless, like the idea that running quickly could change the colour of your thoughts. So the question is not why people believed that space and time were separate. Of course they believed it. The question is what could possibly be strong enough, strange enough, and stubborn enough to make them give it up. What could force the human race to abandon a picture that had earned 200 years of perfect trust, and accept instead that its 2 great stages were secretly one? The answer did not come from the planets, or from gravity, or from anything as large and slow as a comet. It came from something much faster, something that had been sitting quietly in the background the whole time, so common that no one thought to interrogate it. The answer came from light. In the middle of the 1800s, a Scottish physicist named James Clerk Maxwell wrote down a set of equations that pulled together everything then known about electricity and magnetism into a single elegant framework. It was one of the great unifications in the history of science, and by itself it would have secured his name forever. But buried inside those equations was something that no one had asked for, and no one quite knew what to do with. The equations predicted waves, ripples of electricity and magnetism moving through space, and they predicted the exact speed those waves would travel. When Maxwell calculated that speed, it came out to about 300,000 kilometers every second, and he realized with a jolt that this was the speed of light. Light was one of these waves. His equations had accidentally revealed what light was made of. That was the triumph. But hidden inside the triumph was the loose thread that would eventually unravel everything. The speed of light that fell out of Maxwell's equations was just a number, a fixed number, a constant of nature, sitting there in the mathematics with no note attached explaining what it was measured against. And that should have been impossible. Every other speed anyone had ever talked about was a speed relative to something. The train moves at 100 kilometers an hour relative to the ground. The person walks at 5 kilometers an hour relative to the train. Speed is always speed with respect to some chosen thing. But Maxwell's equations gave the speed of light as an absolute value, the same in the raw structure of the equations no matter who you were or how you were moving, with no mention of a reference, as if light did not care what it was measured against. At first, hardly anyone noticed how strange this was. The people who did notice assumed there must be a simple fix, a hidden stage that light was measured against, the same way sound is measured against the air it travels through. They went looking for that hidden stage. They built an instrument delicate enough to detect it, and what they found, or rather what they failed to find, was the first crack in the 200-year-old floor, the first hint that the universe was not built the way everyone was certain it was built. Let me take you into the room where they went looking, and show you the silence they found instead. Part 3. The silence in the light. To understand why the constancy of light was so alarming, you have to understand what physicists expected instead, because they expected something very reasonable, and the universe refused to give it to them. Think about sound for a moment. Sound is a wave, and it travels through the air. Its speed is fixed, but fixed relative to the air it is moving through. If you run toward a source of sound, you meet the incoming waves a little faster. If you run away, they reach you a little slower. The air is the medium, the thing the wave travels in, and every speed makes sense once you remember the air is there. Water waves work the same way. They travel through water. Take away the water and there is no wave. So when Maxwell revealed that light was a wave, everyone naturally asked the obvious question. What is the medium? What is the invisible something that light waves ripple through, the way sound ripples through air? There had to be one. A wave without a medium made no sense to anyone. And so physicists proposed a substance, filling all of space, transparent, frictionless, undetectable by any ordinary means, through which light did its rippling. They called it the luminiferous ether, and although no one had ever seen it or touched it, they were confident it had to be there, because otherwise the speed of light in Maxwell's equations had nothing to be a speed relative to. Now here is where it gets clever. If the ether fills all of space and sits still, and the Earth is racing around the Sun at about 30 kilometers every second, then the Earth must be flying through the ether like a car with the windows down, flying through still air. There must be an ether wind blowing past us, a steady stream of this invisible medium as our planet plows through it. And if you could measure the speed of light very, very carefully, in the direction of that wind and then across it, you should see a difference. Light going upstream against the ether wind should come out just slightly slower than light going across it. The same way a swimmer takes longer to fight upstream and back than to cross a river and return. Find that difference, and you would have caught the Earth's motion through the ether. You would have found the hidden stage that light was measured against, and Newton's absolute space would be confirmed, not overthrown. Everyone assumed that was exactly how it would go. 2 Americans set out to catch that wind. Their names were Albert Michelson and Edward Morley, and in the year 1887 they built one of the most sensitive instruments anyone had ever constructed. It was designed to do one thing, to measure whether light moved even slightly faster in one direction than another, and it was delicate enough to detect a difference far smaller than anyone thought the ether wind could possibly hide behind. Let me put you in that room, because it is one of the quietest, strangest moments in the history of science, and almost nothing happens in it, and that is the whole point. It is a basement laboratory in Cleveland, and the air is cool and still. On a heavy slab of stone floats a delicate arrangement of mirrors, and the stone is not resting on the floor. It is floating on a pool of liquid mercury, a shining silver pond, so that the whole apparatus can be turned as smoothly as a boat drifting on calm water, with no jolt, no tremble. A single beam of light enters, strikes a half-silvered mirror, and splits in two. One half races down a long arm in one direction. The other half races down an arm set at a right angle. Each beam travels about 11 meters, bouncing back and forth between mirrors, and then the two beams return and are brought back together, where they merge into a pattern of light and dark bands called fringes. If the Earth is moving through an ether, then turning the stone should make one beam fight the wind while the other crosses it, and the fringes should slide sideways by nearly half a band, a shift the instrument could see easily. Morley puts his eye to the eyepiece. The stone turns slowly on its Mercury C. The two men watch the fringes, waiting for them to move, and the fringes do not move. Night after night, they do not move. The wind that was supposed to be there is not there. The silence is total. That silence was the sound of absolute space beginning to die. The expected shift was about 4/10 of a single fringe. What Michelson and Morley actually saw was almost nothing, a flicker smaller than a 50th of a fringe, buried in the ordinary noise of the experiment, consistent with no wind at all. And their instrument was not crude. It was precise enough to detect a shift of just a few thousandths of a fringe. The effect they were hunting was not too small to see. It simply was not there. They tried again. They turned the apparatus in every direction. They repeated the measurement at different times of day and different times of year, so that the Earth's motion would point different ways through the supposed ether. It made no difference. Whichever way they aimed their beams, whatever the season, light came back at exactly the same speed in every direction. The Earth's motion through space had no effect on the speed of light whatsoever. It was as if the ether wind did not exist, or as if the Earth somehow dragged its own private pocket of ether along with it, or as if the whole picture were wrong in some way no one could yet name. This was not a small anomaly to be tidied up later. This was a genuine crisis. The speed of light really was the same for everyone, in every direction, regardless of how they moved, exactly as Maxwell's equations had bluntly stated and no one had wanted to believe. Run toward a beam of light, run away from it, fly across its path at 30 kilometers a second on a spinning planet looping around the sun, and the light still approaches you at precisely the same speed, always, without exception. It refuses to add or subtract the way every other speed in the universe does. It just sits there, the same number, no matter what you do. Sit with how strange that is, because everything hinges on it. Imagine you're in a car chasing a beam of light, and you press the accelerator until you are moving at half the speed of light yourself. Common sense says the beam ahead of you should now be pulling away from you at only half its former speed. The way a car you are chasing seems slower once you speed up. But that is not what happens. The beam pulls away from you at the full speed of light, exactly as fast as if you were standing still. You could accelerate to 99% of light speed, pouring unimaginable energy into the chase, and the light would still outrun you at the same full speed, not one bit slower. The gap never closes by even a sliver. The light does not care how fast you go. For a while, some very capable physicists tried to save the old picture with an ingenious patch. Two of them, a Dutchman named Hendrik Lorentz and an Irishman named George Fitzgerald, independently suggested that maybe the ether was real after all, and that the reason Michelson and Morley found nothing was that their instrument had physically shrunk in the direction of its motion by exactly the amount needed to hide the wind. As the arm of the apparatus swung into the ether stream they proposed, it contracted, just enough that the light's longer journey was shortened back into a match and the fringes stayed put. It sounds like a desperate idea, and in a way it was, but the strange thing is that the amount of shrinkage they had to invent was precisely the length contraction that would later fall out of Einstein's theory for free. They had stumbled onto a real effect, but they had the reason backward. They imagined a mechanical squeezing caused by pressure from the ether, a physical force crushing the instrument as it ploughed through the invisible medium. Einstein would show that nothing was being crushed at all, that the contraction was not a force acting on objects but a property of space and time themselves, a feature of the fabric rather than a stress on the ruler. That is the difference between patching a picture and replacing it. Lorentz kept the ether, kept absolute time, and bolted on a contraction to explain away the evidence, and his mathematics worked, in the sense that it gave the right answers. But it required an invisible medium that could never be detected, plus a conspiracy of effects that always hid it perfectly, so that the ether was real yet forever beyond reach. Einstein threw the ether out entirely. He said there was no wind because there was nothing to blow, no medium, no absolute space, and the reason light behaves the same for everyone is simply that space and time adjust themselves to keep it that way. One story kept the old furniture and added a ghost to explain the creaking. The other tore the house down and built a stranger, simpler one in its place. A century of ever more precise experiments, some now sensitive enough to rule out a preferred direction in space to a few parts in 100,000 trillion, has looked for the ether Lawrence wanted to keep and has never found the faintest trace of it. There are really only two ways to react to a fact like that. The first way is to insist that the picture is basically fine and something small must be hiding the effect. And for a while, some very clever people tried exactly that, inventing mechanisms to explain why the ether wind was always perfectly concealed. The second way is to take the fact at face value and follow it wherever it leads, no matter how much it costs. Take it as simply true that the speed of light is the same for every observer, and then ask with a straight face, what would have to be true about space and time for that to be possible? What would rulers have to do? What would clocks have to do? What would you have to give up? The person who took the second path was a 26-year-old clerk working in a patent office in Switzerland, and what he was willing to give up was the one thing everyone else had assumed was untouchable. He kept the speed of light fixed, exactly as the experiment demanded, and to pay for it, he let go of Newton's universal clock. He let go of the single, shared now. He let go of the idea that time is the same for everyone, and the moment he did that, space and time stopped being two things. Let me show you the trade he made, and the price it carried, because it is the hinge on which this entire story turns. Part 4. The Trade Einstein Made. In the year 1905, a young man named Albert Einstein was working as a clerk in a patent office in Bern, Switzerland, examining applications for inventions and thinking in the hours between about the problem of light. He was not a famous professor. He had struggled to find an academic post. He was, by the standards of the physics establishment, a nobody with a steady government job, and in that 1 year he wrote a handful of papers that took the ground everyone was standing on and quietly tilted it forever. His move was not to explain the strange behavior of light away. His move was the opposite. He looked at the fact that the speed of light was the same for every observer, the fact that had thrown everyone else into crisis, and instead of treating it as a puzzle to be solved, he treated it as a law to be obeyed. He decided to build a new physics on top of it, taking it as an unbreakable starting rule rather than a mystery to be dissolved. It was the intellectual equivalent of finding a locked door that no key would open, and rather than trying harder keys, deciding that the door was not meant to open, and building the whole house around that fact. He started from just two simple statements, and everything else followed from them with a kind of ruthless logic. The first statement was that the laws of physics are the same for everyone moving steadily, in any straight, smooth motion. If you are in a sealed cabin gliding along at a constant speed, there is no experiment you can do inside that cabin to tell whether you are moving or standing still. This was not new. Even Newton would have agreed with it. It is why you can pour a drink on a smooth aircraft flight exactly as you would at home, why nothing inside a steadily moving vehicle betrays its motion. Motion at a constant speed is, in a real sense, indistinguishable from rest. The second statement was the dangerous one. The speed of light is the same for every such observer, no matter how they are moving or how the source of the light is moving. This was simply the Michelson and Morley result, stated as a principle. Light travels at its one fixed speed, about 300,000 kilometers every second, and every observer who measures it, whatever their own motion, gets that same number. Not approximately, exactly. Now watch what happens when you hold both of those statements at the same time, because this is the moment the two great stages begin to merge, and it is worth going slowly. Picture two people. One is standing on a station platform. The other is on a train rushing past at enormous speed. The person on the train switches on a flashlight and measures how fast the light leaves it. They get the speed of light, fine. But the person on the platform also watches that same beam of light and measures its speed as it passes them. By every ordinary rule, they should measure a different number. The light was fired from a moving train, so surely the train's speed should add to the light's speed. The way a ball thrown forward from a moving vehicle flies faster than a ball thrown while standing still. The platform observer should see the light moving faster than the train passenger does, but they do not. Both of them measure exactly the same speed of light. The train's motion adds nothing. This is not a mistake, and it is not a matter of instruments being too crude. It is the plain, verified behavior of the universe, and it seems, at first, completely impossible. How can two people moving at different speeds, watching the same beam of light, both measure that light moving at the same speed relative to themselves. Let me make the impossibility concrete, because feeling it is the whole point. Suppose the train is somehow moving at half the speed of light, and the passenger shines a flashlight forward, down the length of the train. The passenger measures the light leaving them at the full speed of light naturally. Now ordinary sense says the person on the platform, watching a beam fired forward from a train that is already moving at half of light speed, should measure that light racing past at 1.5 times the speed of light, the train speed added to the light speed. But that number is forbidden. Nothing can exceed the speed of light, and more to the point, the platform observer measures the beam moving at exactly the speed of light, no faster, the same value the passenger got. The half a light speed of the train has simply vanished from the sum. It did not add. It could not add, because if it had, the two observers would disagree about the speed of light, and that is the one thing the universe will not permit. So where did the train speed go? It did not go anywhere, because it was never really a matter of speeds refusing to add. It was space and time quietly rearranging themselves so that the total comes out right. For the platform observer, the passenger's clock is running slow, and the passenger's ruler is short, and their sense of which events count as simultaneous is tilted, and all of those adjustments conspire with perfect precision to turn what should have been 1.5 light speeds back into exactly 1. The constancy of light is not maintained by some rule about adding velocities. It is maintained by the flexibility of space and time themselves, bending in exactly the way needed, every time, for everyone. And that is why the price of keeping light constant had to be paid in the currency of space and time. There was nothing else soft enough to bend. There is only one way out, and it is the escape hatch Einstein was brave enough to walk through. Speed is distance divided by time. It is how far something travels divided by how long the trip takes. If two observers moving differently both measure the same speed for the same beam of light, and yet they are moving differently relative to that beam, then they cannot possibly agree about the distances and the times involved. Their meters and their seconds must disagree in just the right way to keep the speed of light identical for both of them. The only way to keep light speed fixed for everyone is to let space and time themselves become flexible, stretching and shrinking from one observer to the next, so that the ratio, the speed, always comes out the same. Read that again, because it is the whole idea in miniature. To hold the speed of light constant for everyone, distances and durations have to bend. The rigidity has to go somewhere, and Einstein put it into the one place no one had dared to touch. He made the speed of light the rigid, unchanging thing, the fixed point around which everything else turns, and in exchange he let space and time themselves become soft and negotiable, different for every observer depending on their motion. That was the trade. Keep the speed of light absolute, and give up absolute space and absolute time. And notice what a strange bargain it is. For 2 centuries everyone had assumed that space and time were the fixed, reliable backdrop, and that speeds were the flexible things measured against them. Einstein turned that completely inside out. He made a speed, the speed of a light, into the fixed backdrop, and turned space and time into the flexible things. The stage and the actors swapped roles. Once you accept that trade, some very concrete consequences follow, and they are not vague or philosophical. They are precise, and they have all been measured. A clock that is moving relative to you runs slow, ticking more sluggishly than your own, and the faster it moves, the more it lags. A ruler that is moving relative to you shrinks along the direction it is travelling, coming out shorter than it would if it sat still in your hands. And 2 events that happen at the same moment for you can happen at different moments for someone moving past you. Time itself is stretched, length itself is squeezed, and the very meaning of at the same time comes apart, all of it forced on us by the single stubborn fact that light will not change its speed no matter what. I want to be clear that none of this is a matter of how things look, or of signals taking time to reach you, or of any illusion that a smarter measurement could correct. Einstein was not describing a trick of perception. He was describing what is actually true of space and time for each observer. The moving clock does not merely appear to run slow, it runs slow. The moving ruler does not merely look shorter, it is shorter in the frame of the person watching it move. These are real features of a universe in which the speed of light is the one fixed thing, and space and time are the things that give way. And already, quietly, without our having said the word yet, space and time have stopped being independent. Look at what just happened. The speed of light ties them together, because light's speed must stay fixed. Any change in how you measure distance forces a matching change in how you measure time, and the other way around. You can no longer adjust one without the other responding. They have become locked to each other, two ends of a single beam that light holds rigid between them. Pull on space and time answers. Pull on time and space answers. They are no longer two separate stages. They have become a single mechanism, and the speed of light is the axle they both turn on. Of all the consequences of Einstein's trade, there is one that unsettles people more than any other, because it reaches into the most basic thing you believe about the world. It is the death of the shared present, the discovery that there is no single now, that the word simultaneous loses its universal meaning, and that two events which happen together for you may happen one after the other for someone else, with neither of you mistaken. This is where the loss of absolute time stops being an abstract statement and becomes something that touches your own sense of reality. Let me slow all the way down and show you exactly how the universe took the present moment away from us. Part 5. The death of now. The single hardest thing to give up, the belief that lies underneath all the others, is the belief in a universal now. So let me take it apart carefully, using the same kind of simple picture Einstein himself used, because once you see it, you cannot unsee it. Imagine a very long train moving down a straight track at a steady, enormous speed. Standing beside the track on the embankment is a person we will call the outside observer. Sitting exactly in the middle of the train is a second person, the passenger, riding along with it. Now imagine that two bolts of lightning strike the track at the very same instant, one at the front of the train and one at the back, each leaving a scorch mark on both the train and the ground, so we can talk about exactly where they hit. The outside observer is standing at the midpoint between the two scorch marks on the ground, the same distance from the front strike as from the back strike. The light from each flash races toward them at the fixed speed of light. Because the two flashes happened at the same moment, and because they are the same distance away, their light arrives at the outside observer at exactly the same instant, one flash from the left and one from the right, reaching the eyes together. The outside observer says, with complete confidence, that the two strikes were simultaneous. They happened at the same time, and for the outside observer, that is simply true. Now think about the passenger, sitting in the middle of the train, and here is where the ordinary picture quietly falls apart. At the moment the lightning strikes, the passenger happens to be right next to the outside observer, lined up at the midpoint. But the passenger is moving, carried forward by the train toward the front of the train and away from the back. The light from both flashes still travels at the same fixed speed, because it always does, for everyone. But while that light is on its way, the passenger is moving. They are rushing toward the flash at the front and pulling away from the flash at the back. So the light from the front reaches them first, a moment before the light from the back catches up. The passenger sees the front flash, and then, slightly later, the back flash. And the passenger reasons exactly as carefully as the outside observer did. They know light travels at a fixed speed. They know they are sitting at the middle of the train, the same distance from both ends. The light from the front reached them before the light from the back, so, they conclude, the front strike must have happened before the back strike. For the passenger, the two events were not simultaneous at all. One came first. Stop here, because this is the moment everything changes. Which one is right? The outside observer, who says the strikes were simultaneous, or the passenger, who says the front one happened first? And the answer that took physics so long to accept, is that both of them are right. There is no third, higher viewpoint that settles it. There is no true answer hiding behind their two answers. The outside observer really did have the flashes arrive together. The passenger really did have the front flash arrive first. Both measured correctly, both reasoned correctly, and they disagree about whether two events happened at the same time. This is not about the delay of light reaching their eyes. We have already accounted for that. It is not that one of them is being fooled by the travel time of the signals. Both of them have properly corrected for how long the light took to arrive. When you do all the bookkeeping honestly, they still disagree, and neither disagreement can be argued away. The plain truth is that whether two separated events happen at the same time depends on how you are moving. Simultaneity, the very idea of at the same moment, is not a fact about the universe. It is a fact about you, about your particular motion, and observers in different states of motion slice the moment differently. Now let this sink all the way in, because it is one of the strangest things a human being can know, and it is worth feeling, not just understanding. You believe right now that there is a single present moment that the whole universe is sharing with you. You believe that as you sit there, this instant is ticking along everywhere at once, that there is a fact of the matter about what is happening now on the other side of the world, now around a distant star, now at the far edge of the galaxy. That belief feels like bedrock. It feels less like an opinion and more like the obvious shape of reality. And it is wrong. There is no universal now. There is no cosmic presence sweeping across everything in step. When you point at some distant place and say what is happening there right now, a traveller drifting past you at that same moment would draw the line of now at a different angle, sweeping in events you would call the future, and leaving out events you would call the past, and there is no way to say which of you has found the real present, because there is no real present to find. Each of you gets your own. Everyone does. The single, shared moment you assumed the whole cosmos was living in together simply does not exist, and it never did. This is what it truly means to give up absolute time. It is not a small technical adjustment. It is the loss of the shared present, the discovery that now is a private thing, cut to a slightly different angle for every observer, with no master version anywhere. The universe does not have one clock. It has as many nows as there are ways of moving, and they slice through reality in slightly different directions, and all of them are equally valid, and none of them is the true one. And notice again what this is doing to the wall between space and time, because that is where we are heading. In the old picture, two events either happened at the same time or they did not, full stop, and separately from that, they either happened at the same place or they did not. Time facts were time facts, and space facts were space facts, and never the two should mix. But we have just watched them mix. Whether two events are simultaneous, which sounds like a pure question about time, turns out to depend on your motion through space. Change how you move through space, and you change what counts as happening at the same time. The when has become tangled with the how you move, which is to say tangled with the where. The two great stages are leaking into each other, right in front of us, and we have barely begun. There is something almost tender hidden in this, if you sit with it long enough. The reason we all feel so certain that there is one shared now is that, at the ordinary speeds of human life, the disagreement is unimaginably tiny. For the train and the platform, or for you and a passing car, or even for you and a jet overhead, the different nows are out of step by amounts so small that no sense you possess could ever detect them. Fractions of a second, spread across the events of the world. So evolution never had any reason to teach you the truth. Your brain built a single shared present because at human speeds that is a nearly perfect approximation, and a nearly perfect approximation is all a living thing has ever needed. The universal now is not a lie your senses tell you out of malice. It is a mercy, a simplification that works so well you never noticed it was a simplification. Let me give you a feel for just how small the effect is at human speeds, because the smallness is the whole reason it stayed hidden for so long. Suppose you and a friend synchronized two perfect clocks, and then your friend climbed into a car and drove around for 50 years at highway speed while you stood still. The difference their motion would build up between the two clocks, over half a century of driving, would amount to roughly a millionth of a second. A single millionth of a second spread across 50 years. No wonder no one ever noticed. The disagreement about the present that we have been describing is, at the speeds bodies actually move, so far below the threshold of any human sense that it might as well not exist, and for all of ordinary life it does not. But the effect does not stay small when the distances grow enormous. Stretch the same situation across the galaxy instead of across a town, and the tiny angular difference between two observers' nows, multiplied by tens of thousands of light years, can sweep across years or even centuries of events. Two people strolling past each other on a sidewalk at a gentle walking pace would slice the present moment on a planet far across the galaxy, at nows that differ by days. Their disagreement is invisible next to each other, and enormous across the cosmos, and it is the very same disagreement, the same slight tilt of the same slice, scaled up by distance. The shared present does not merely bend a little, reach far enough, and it comes apart completely. But it is a simplification, and once you know that, the world quietly changes shape. Every person you have ever stood beside was living in a now very slightly their own. Every moving thing carries its own present with it. And the reason all of this holds together, the reason the universe does not dissolve into pure chaos, with everyone disagreeing about everything, is that underneath the disagreements there is something they all still share. Something absolute that survives no matter how you move. It is not space, and it is not time, taken separately. It is a particular combination of the two, and finding it is the next step in our walk. Let me show you how the disagreements about clocks and rulers become, under the surface, a single unbreakable agreement. Part 6. When clocks and rulers begin to lie. To see how space and time lock together, it helps to build the simplest possible clock, one made of nothing but light, because a clock made of light has no choice but to obey the one rule we now know the universe insists on. Picture two mirrors facing each other, one on the floor and one on the ceiling, with a single pulse of light bouncing straight up and down between them. Every time the light completes one round trip, up to the top mirror and back down, call that one tick. This is a real clock. The steadier the light, the steadier the ticking, and since light always travels at the same fixed speed, this is about as reliable a clock as you could ever want. Hold it still in your hands and it ticks away, up and down, marking time perfectly. Now hand that clock to someone on a train and watch it go past you at high speed. From their point of view, sitting with the clock, nothing has changed. The light still goes straight up and straight down, the same short trip, tick, tick, tick. But from your point of view, standing outside as the train rushes by, the light does not go straight up and down at all. While the light is travelling from the floor mirror up to the ceiling mirror, the whole clock is moving sideways, so the light has to travel along a slanted diagonal path to catch up with the ceiling mirror in its new position. Then it slants back down to meet the floor mirror, which has also moved on. Instead of a short up and down line, you see the light tracing a long zigzag, a series of stretched diagonals. Here is the part that changes everything. That diagonal path is longer than the straight up and down path. The light has farther to go, and the light cannot go any faster to make up for it, because the speed of light is fixed, the same for you as for them, no exceptions. If the light has a longer distance to cover, and it cannot speed up, then it must take more time to complete each round trip. Each tick of the moving clock as seen by you takes longer than each tick of the same clock at rest. The moving clock runs slow, not because anything is wrong with it, not because it is broken or poorly made. It runs slow purely because it is moving, and because light refuses to travel any faster to compensate for the longer path it now has to take. This is time dilation, and it is not a quirk of clocks made of light. It is time itself. Any clock on that train slows by exactly the same amount, because they all have to agree with each other, otherwise the passenger could compare two clocks and detect their own motion, which the laws of physics forbid. A mechanical watch, a beating pulse, the decay of a radioactive atom, the aging of a living body, all of it slows together, in perfect lockstep when seen from outside. Time on the moving train genuinely passes more slowly, as measured by you standing still, and the faster the train goes, the greater the effect. At everyday speeds it is so small that no instrument in ordinary life could catch it. But push toward the speed of light, and it grows without limit. At about 87% of light speed, moving clocks run at half your rate. At 99% they slow to about a seventh. Push closer still, and time on the moving object crawls almost to a standstill, from your point of view, while the traveller notices nothing unusual at all. There is a matching effect for space, and it is the mirror image of the first. Just as moving clocks run slow, moving objects shrink along the direction they're travelling. A ruler flying past you lengthwise comes out measurably shorter than the same ruler held still, squeezed along its line of motion, and the closer it comes to the speed of light, the more it is compressed. At the same speeds where clocks slow to half, lengths shrink to half. Time stretches and space squeezes, and the two effects are governed by exactly the same factor, growing together as you approach light speed, because they are not really two separate effects at all. They are two faces of one adjustment the universe makes to keep the speed of light the same for everyone. Before we go there, I have to confront something that sounds like a contradiction, because facing it will actually strengthen the point. I said that a moving clock runs slow as seen by you standing still. But remember the first principle we started from, that steady motion is relative, that there is no way to say who is really moving. From the passenger's point of view, they are the one sitting still, and you and your whole world are gliding past in the other direction. So the passenger, looking at your clock, sees your clock running slow. Each of you sees the other's clock ticking more sluggishly than your own, and that sounds impossible. How can my clock be slower than yours while your clock is slower than mine? Surely only one of us can really be behind. The resolution is the thing we have been circling all along. There is no single answer to whose clock is behind, because comparing two separated clocks requires a notion of at the same time, and we have already seen that at the same time is personal, sliced differently by each observer. You and the passenger are not disagreeing about a fact. You're cutting the fabric at different angles, and each of you, slicing your own way, honestly finds the other's clock lagging. There is no paradox, only two valid views of one fabric. But suppose you do something that breaks the symmetry. Suppose one of a pair of twins climbs into a ship, flies off at close to the speed of light, turns around and comes home, while the other twin stays on Earth. When they reunite, the travelling twin is genuinely younger, having lived through fewer years, not in appearance but in fact. And this time there is no symmetry to hide behind, because the traveller is the one who turned around, who changed their motion, who took the bent path through space-time while the stay-at-home twin went straight. The reason the traveller aged less is the same reason two roads between the same two towns can have different lengths. The time between two meetings is not a fixed universal quantity. It is the length of the particular path you take through the fabric, and a path that swings out through space and comes back is, in the strange geometry of space-time, a shorter path through time. The travelling twin did not cheat time. They simply took a shorter route through it, measured in the only way space-time knows how to measure. Now I want to show you the piece that turns all of this from a collection of strange effects into a single unmistakable statement, and it is the moment the wall between space and time comes down for good. When Einstein worked out the exact rules for translating one observer's measurements into another's, the rules for taking your meters and seconds and converting them into the meters and seconds of someone moving past you, those rules had a feature that should stop you cold. To calculate the time that the moving observer assigns to an event, you do not just use your time, you have to mix in the position of the event, its location in space. The moving observer's clock reading depends not only on when something happens in your frame, but on where it happens. Their time is built partly out of your space. Read that slowly. In the equation that gives the moving person's time, a distance appears. Space reaches into the formula for time and helps to determine it. And in the matching equation, the reverse happens too, so that the moving person's measurement of distance depends partly on your time. Each of them builds their space partly out of your time, and their time partly out of your space. The two quantities are not just affecting each other from a distance, they're woven into each other at the level of the basic arithmetic. You literally cannot compute one without the other. This is the mathematical core of everything we are circling toward. Space and time are not two separate quantities that happen to influence one another. They are two components of a single thing, and when you change your motion, that thing gets resorted, with some of what one observer called time reassigned to what another observer calls space, and the other way around. It is exactly like two people describing the same object using different mixtures of the same underlying stuff. What one of them files under time, the other files partly under space, and neither filing is wrong, because underneath both of them there is only one object being described. Think about what this means for the question we started with, the question of whether space and time can be pulled apart. To pull them apart, you would need a clean, universal way to say this much of a situation is time and that much is space, a division everyone would agree on. But we have just seen that there is no such division. Every observer sorts the single underlying reality into their own personal mixture of space and time, and the sorting depends entirely on how they are moving. There is no observer-independent line separating the two, because the line is not a feature of the universe, it is a feature of your motion. Move differently, and the line moves with you. That is what it means to say space and time cannot be pulled apart. There is nothing to pull apart into, because the two things you would be separating are not really two things. They are one thing cut at an angle that only you have chosen. And underneath all of this disagreement, all these clashing clocks and shrinking rulers and personal nows, there had to be something solid, something every observer would agree on no matter how they moved. Physics does not tolerate a universe where nothing is fixed. There had to be an anchor. And the man who found that anchor was not Einstein. It was Einstein's former mathematics teacher, a man who had once thought of his brilliant student as something close to a lost cause, and who now, watching that student rewrite physics, saw a shape in the equations that even Einstein had not yet noticed. He saw that the disagreements were the surface, and that beneath them lay a single, four-dimensional object, and he gave it a name. Let me introduce you to the man who took two things, and in one lecture welded them into one. Part 7. The man who turned two things into one. The man's name was Hermann Minkowski, and there is a small human irony at the centre of his story that I find impossible to resist. Years before any of this, Minkowski had been one of Einstein's mathematics professors at the Polytechnic in Zurich. He was a gifted mathematician, precise and demanding, and his student Albert Einstein was, by his own later account, not exactly a model of diligence. Einstein skipped lectures. He preferred to study what interested him and ignore the rest. And Minkowski, watching this restless young man drift through his classes, is said to have called him a lazy dog, someone who would never amount to much in mathematics. So imagine the quiet reversal, a few years later, when that same lazy dog produced a theory that turned physics upside down, a theory built on exactly the kind of careful reasoning about space and time that a mathematician could love. Minkowski read Einstein's work, and instead of dismissing it, he did something generous and profound. He looked underneath it. He took the strange collection of effects, the slowing clocks and shrinking rulers and personal nows, and he asked what mathematical shape could produce all of them at once, and he found it. He realized that all of Einstein's results were the natural behavior of a single four-dimensional geometry, a unified structure in which space and time were not separate at all, but were woven together into one continuous fabric. He gave that fabric a name we still use. He called it space-time. In the year 1908, Minkowski stood up to announce this in public, and the words he chose have outlived nearly everything else said that day. Let me take you into that lecture hall, because it is a moment worth standing inside. It is the 21st of September, 1908, in the German city of Cologne. A gathering of natural scientists and physicians fills the room, mathematicians and physicists among them, and a heavy-set man with a serious face rises to speak. He's about to reframe the work of the former student he once wrote off, and he does not begin with equations or apologies. He begins with a kind of prophecy. The views of space and time he wishes to lay before them, he says, have sprung from the soil of experimental physics, and therein lies their strength. And then he delivers the sentence. From this hour on, he tells the room, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. You can almost feel the words land, the older men shifting in their seats, the younger ones sensing that the floor of physics has just been renamed beneath them. He speaks of a four-dimensional world, of points that are not places or moments but both at once, events fixed in a single fabric. He does not know, standing there, that he has only 16 months left to live, but the idea he is describing will outlast everyone in the hall, and it will turn out to be the true shape of the universe. Hold on to that word he used. Shadows. Space by itself and time by itself are doomed to fade away into mere shadows. It is one of the most precise metaphors in the history of physics, and it deserves to be unpacked slowly, because it explains everything we have been struggling toward. Think about a single solid object, say a pencil, held up in the light so that it casts a shadow on the wall and another shadow on the floor. The shadow on the wall has a certain length. The shadow on the floor has a certain length. Now turn the pencil. As you rotate it, the wall shadow grows longer while the floor shadow grows shorter, or the reverse. The two shadows trade length back and forth as you turn. If two people each looked at only one shadow and argued about the pencil's true length, they would never agree because each of them is seeing only a projection, a flattened version of the real object cast onto their particular surface. Neither shadow is the pencil. Neither shadow by itself tells you the truth, but the pencil itself, the solid thing in the middle, never changes its length at all. It is completely fixed. Only its shadows change, and they change only because you are turning it. This is exactly what space and time are. They are the two shadows. The real object is space-time, the four-dimensional fabric, and it is fixed and absolute, the same for everyone. But space and time are the shadows it casts, and when you change your motion, it is like turning the object so the shadows shift. Some of what one observer sees as time gets cast, for another observer, partly as space. Your measurement of duration and your measurement of distance are the wall shadow and the floor shadow of a single underlying thing, and that is why two observers moving differently disagree about them. They are not looking at different realities. They are looking at different shadows of the same reality from different angles, and just as the pencil has a true length that never changes no matter how you turn it, space-time has a true measure between any two events that never changes no matter how you move. This is Minkowski's great gift, and it is the anchor we were promised. Take any two events, say a flash here and a flash there, a little apart in space and a little apart in time. Different observers will disagree about how far apart they are in space, and they will disagree about how far apart they are in time. But if each observer combines those two disagreements in a particular way, taking the time separation and the space separation and folding them together according to one specific rule, every single observer, no matter how they are moving, gets exactly the same answer. That combined quantity is called the space-time interval, and it is the true absolute distance between two events in the four-dimensional fabric. It is the pencil. The separate space and time measurements are only its shadows. Let me make that concrete with the simplest possible case, because it shows the machinery working. Imagine you are sitting still, and you blink twice. One blink and then, 5 seconds later, a second blink. For you, those two events, the two blinks, happen at the very same place, your own eyes, separated by 5 seconds of time and no distance at all. The separation between them is pure time. Now imagine someone flying past you in a fast ship watches the same two blinks. In their frame, you and your eyes were moving the whole time, so between your first blink and your second, your eyes travelled some distance across their view. For them, the two blinks happened at two different places, separated by both time and space. You say the blinks were separated by pure time and zero distance. They say the blinks were separated by a mixture of time and distance. You disagree completely about how much of the separation is time and how much is space, and yet, if each of you takes your own numbers and folds them together by the interval rule, combining the time part and the space part with that one specific recipe, you both arrive at precisely the same answer. The disagreement about time and the disagreement about space cancel out exactly, leaving one shared quantity that you both agree on. Your pure time separation and their mixed separation are two shadows of the same interval, the same pencil, seen from two angles. This is not a coincidence, and it is not approximate. It is exact, and it holds for every pair of events and every possible observer in the universe. Underneath all the disagreement about clocks and rulers and simultaneity, there is one number that everyone shares, and that number is the real distance in the fabric. It is the closest thing the universe has to bedrock, and it is made of space and time together, never either one alone. This is the fullest sense in which space and time cannot be pulled apart. It is not merely that they influence each other, or that they mix under motion, though both of those are true. It is that the thing which is actually real, the thing every observer agrees on, is neither space alone nor time alone, but the specific weld of the two that Minkowski found. Space taken by itself is a shadow. Time taken by itself is a shadow. Reality is the union. Pull them apart, insist on treating them as two independent things, and you are left holding two shadows and no pencil, two projections of a truth you have thrown away. The universe keeps its books in space-time. Space and time are just the two columns different observers happen to use, and the columns trade entries depending on who is doing the accounting, but the total, the interval, is always the same. There is something almost unbearably poignant in the timing of all this. Minkowski gave physics the geometry that would carry Einstein's ideas for the next century, the language that general relativity itself would later be written in. And then, just months after that lecture, in January of 1909, he was struck down suddenly by a burst appendix and died, at the age of 44. He did not live to see his four-dimensional world confirmed, did not live to see clocks flown around the planet and come home disagreeing exactly as his geometry demanded, did not live to see the fabric he named turn out to be the real architecture of the cosmos. The man who told the world that space and time were doomed to fade into shadows became, himself, a shadow far too soon, leaving behind an idea that refused to fade at all. But an idea like this cannot rest on a metaphor alone, however beautiful. Saying that space and time are shadows of one object is lovely, but a physicist wants to know the mechanism. If they really are two views of one fabric, then there ought to be a precise sense in which changing your motion turns that fabric, the way turning a pencil swings its shadows, and there is. Changing your speed really is a kind of rotation, a turning of the fabric, one that swaps time for space and space for time by exactly the amount needed. Once you see motion itself as a rotation in space-time, the last of the strangeness settles into place, and the whole thing starts to feel not bizarre but almost inevitable. Let me show you how simply picking up speed is, quite literally, a way of turning the fabric of the universe. Part 8. One fabric, and you can turn it. The idea that changing your speed is a kind of rotation sounds, at first, Like a strange thing to say. Rotation is what a spinning top does, what a steering wheel does, a turning in space. What could it possibly mean to say that simply speeding up is a rotation? But this turns out to be the cleanest way to understand the whole business, and it starts with an ordinary object sitting on an ordinary table. Put a pencil flat on a table in front of you and look straight down at it. It points in some direction. Now describe that direction using two numbers, how far the pencil extends left to right, and how far it extends toward you and away from you. Call the first one its width, and the second one its depth. Together, those two numbers pin down which way the pencil is pointing. So far, so simple. But now, without moving the pencil at all, get up and walk around the table and look at it from a different side. From your new position, the very same pencil has a different width and a different depth. What you called width from the first seat has become partly depth from the second, and what you called depth has become partly width. The pencil has not changed one bit, only your viewpoint has, and because you turned your viewpoint, the two numbers that describe the pencil have traded some of their value back and forth between them. Here is the crucial thing about that little exercise. Nobody would ever say that width and depth are two separate substances. Nobody would insist that there is a true, universal amount of width that a pencil has, independent of who is looking. We all understand, without being taught, that width and depth are just two directions we happen to measure, that they trade off when you change your angle, and that the only thing that is really fixed about the pencil is its total length, the thing that stays the same no matter how you walk around it. Width and depth are personal, length is real, and the reason width and depth trade off is that they are both projections, both shadows, of the one real length, cast along whatever directions you happen to choose. Now hold that picture, and let me tell you the single most important sentence in this entire story. Space and time are related to each other in exactly the same way that width and depth are. When you change your motion, you are turning your viewpoint in the four-dimensional fabric, and just as walking around a table trades width for depth, moving through space-time trades space for time. What one observer measures as a pure interval of time, another observer, moving differently, measures as partly time and partly space, because the second observer is looking at the same fixed space-time object from a turned angle. Speeding up is not like walking around a table in the ordinary 3 dimensions, you know. It is like walking around the table in a fourth direction, the time direction, and the result is the same. The two numbers trade. This is the answer to the question we started with. This is why space and time cannot be pulled apart. You cannot pull them apart for the same reason you cannot pull width apart from depth. Ask someone how much of a pencil's extent is width and how much is depth, and the only honest answer is another question. From which angle are you looking? The split into width and depth is not a property of the pencil, it is a property of your viewpoint. And in exactly the same way, ask how much of the separation between two events is space, and how much is time, and the only honest answer is, from what state of motion are you asking? The split into space and time is not a property of the universe, it is a property of your motion. There is no observer-independent way to draw the line, because the line is drawn by your velocity, and every velocity draws it a little differently. Space and time are inseparable not because they are glued together, but because they were never two things in the first place. They are one fabric, and the boundary you thought you saw between them is just the particular angle at which you happen to be cutting through it. I want to be careful and honest here, because there is one difference between turning in space and turning in space-time, and that difference is going to matter enormously later. When you rotate a pencil in ordinary space, width and depth trade off in a way that keeps a familiar total fixed, the plane length you would measure with a ruler. When you turn in space-time by changing your speed, space and time also trade off, but the total that stays fixed is not computed in quite the familiar way. It is the space-time interval, and in the rule for the interval, space and time enter with opposite signs. Time counts one way, and space counts the other way, and it is that single difference of sign, that one small asymmetry buried in the geometry, that keeps space-time from being just 4 interchangeable directions. For now, simply file that away. Space and time turn into each other under motion, almost like 4 directions of one thing, but not quite, because of one quiet minus sign. We will come back to that sign at the very end, and when we do, it will turn out to be the reason you have a past you can remember and a future you cannot. But set that subtlety aside for a moment and feel the force of the main idea, because it is enormous. Every time you speed up or slow down, In a car, on a plane, walking across a room, you are turning yourself in the four-dimensional fabric of the universe, however slightly. You are resorting the world's events into a slightly different mixture of space and time. The now you carry, the line you would draw through the cosmos to mark the present, swings ever so gently as you change your motion, sweeping through the fabric like the hand of a compass. At the speeds of ordinary life, the swing is unimaginably tiny, far too small to notice. But it is real, and it is happening, and it is the same effect that, pushed to enormous speeds, slows clocks to a crawl and shrinks rulers to slivers. The dramatic effects near the speed of light and the invisible ones in your living room are not different phenomena. They are the same turning of the same fabric, gentle when you move slowly, violent when you move fast. And this gives us a way to feel something about ourselves that is genuinely astonishing, something that is true of your body at this exact moment, sitting wherever you are sitting. If moving through space is a turning in the fabric, a trading of time for space, then there is a precise sense in which everything, including you, is always moving through the fabric at one fixed rate, and all that ever changes is the direction. When you sit perfectly still, you are pointed almost entirely in the time direction, moving through time as fast as anything can. When you get up and walk, you turn slightly, tipping a sliver of that motion out of time and into space. You never speed up or slow down your total motion through the fabric. You only ever change which way it points, and that fixed rate at which you are always moving through space-time, the total speed you can never change, turns out to be the one speed we have been circling this entire time. You are right now moving through the fabric of the universe at the speed of light. You always have been. You cannot stop. Let me show you exactly what that means, because it is the strangest and most personal thing I am going to tell you tonight. Part 9. You are already moving at the speed of light. I told you at the very start that by the end of tonight, sitting still in a quiet room would never look the same again. This is the part where that promise comes due, so let me lay it out as plainly and carefully as I can, because it is true and it is happening to you as you listen. Everything in the universe is always moving through the fabric of space-time at exactly one speed, and that speed is the speed of light. Not close to it, exactly it. This is not a poetic way of speaking. It is a precise statement about the four-dimensional geometry Minkowski uncovered. Every object has a kind of motion through space-time, a combined motion that merges how it moves through space with how it moves through time, and when you work out the total, it always comes to the same value for everything, everywhere, always. The speed of light is not just the speed of light beams, it is the one speed at which every single thing travels through the fabric without exception, and the only freedom anything has is to choose the direction of that motion, never its amount. Now here is what that means, and it is the most beautiful idea in all of relativity. There are, roughly speaking, two directions you can point this fixed motion. You can move through space, or you can move through time. And because the total is fixed, whatever you spend on one you take from the other. They share a single budget, and the budget is always full, and it is always exactly the speed of light. When you sit perfectly still, not moving through space at all, you are spending your entire budget on motion through time. Every bit of that fixed speed is pointed in the time direction, and that means, when you are at rest, you are moving through time as fast as it is possible for anything to move through time. Sitting still is not the absence of motion. Sitting still is racing through time at full throttle, the maximum rate the universe allows, 1 second of your time for every second there is, because every scrap of your motion through the fabric is aimed straight at the future, and none of it is being spent anywhere else. And when you get up and move through space, you have to pay for it. You take some of that motion out of the time direction and redirect it into space. Your total speed through the fabric does not change. It cannot change. So the only way to move through space is to borrow from your motion through time. And the instant you do, your clock slows down. Not as a side effect, as the direct necessary consequence of spending some of your fixed budget on space instead of time. This is time dilation, seen from the inside. A moving clock runs slow because the moving object has diverted part of its motion out of the time direction and into the space direction, leaving less for time. Motion through space is not free. It is always, exactly, stolen from motion through time. Let me slow all the way down and put you inside this, because it is not an abstraction. It is the physics of your own body right now. You're sitting there, as still as you can manage, and you feel motionless. You feel like nothing is happening, but in the fabric of space-time you are not still at all. You are hurtling forward through time at the speed of light, carried toward the next second and the next with the full unstoppable motion that the universe gives to everything. Feel the seconds passing, one after another, steady and sure. That passing is your motion. That is you, travelling through the time direction of the fabric at the greatest speed there is. Now, very slowly raise one hand. In the act of lifting it, you tipped a sliver of your motion out of the pure forward rush of time and spent it on crossing a little space. And for that instant, the atoms of your moving hand aged a hair more slowly than the rest of you, fell a whisper behind the clock on the wall, because they spent part of their budget on space and had that much less left for time. It is far too small for any sense you own to feel. It is not too small to be real. You have been travelling at the speed of light your entire life, and you never once felt the wind. Imagine, just for a moment, what it would take to feel it. Suppose you could stand up and begin moving faster and faster, not at the gentle pace of a human body, but faster, up toward the speed of light itself. As you did, you would be turning harder and harder in the fabric, tipping more and more of your motion out of time and into space, and your clock would slow, not by the invisible slivers of ordinary walking, but sharply, noticeably, until at speeds near light itself your passage through time would nearly stop. If you could somehow reach the speed of light exactly, and no object with mass ever can, you would have turned so far that your entire motion pointed into space, with none left over for time. Your clock would freeze. This is exactly why light itself does not age. A particle of light spends its whole existence moving through space at the full speed of light, which leaves nothing at all for motion through time, so from the light's own point of view, no time passes between the instant it is born in a distant star and the instant it lands in your eye, even if that crossing took 1 billion years by our clocks. Light, then, is the one thing that has traded away all of its motion through time. You are its opposite. Sitting still, you have traded away all of your motion through space and kept every scrap of your motion through time, and that is a quietly staggering thing to be. You and a beam of starlight are two ends of the same single choice. The light gave everything to space and has no time at all. You, in your stillness, give everything to time and cross no space. Everything else in the universe lives somewhere in between, dividing the one fixed motion between the two directions, and that division is the only freedom anything has. You cannot go faster than the light, and you cannot go slower than your own stillness, because both of those are simply the two extreme ways of pointing a motion whose total never changes. You have never been still, and you can never truly rush. You have only ever been turning one fixed arrow between the future and the door. Sit with this, because it changes something quiet and fundamental about what it means to be still. You have spent your whole life believing that stillness is rest, that when you stop moving you have come to a kind of zero, a state of not going anywhere. The truth is the exact opposite. When you are still, you are moving through time faster than you ever will again. The moment you begin to move through space, you slow your passage through time, however slightly. So the fastest you will ever travel through anything is right now, sitting quietly, doing nothing, pouring the entire speed of light into your journey toward tomorrow. You have never been still. There is no such thing. What you call stillness is the maximum speed the universe permits, aimed straight at the future, and the only thing you have ever been able to do is turn a little of it sideways. There is a strange comfort hidden in this, and a strange vertigo, and they arrive together. The comfort is that you are never left behind. Whatever happens, however slow your life feels, you are always moving forward through the fabric at the fullest possible rate, carried toward the future as fast as anything can be carried. Time is not something you can fall out of. You're made of motion through it. The vertigo is that you cannot stop, cannot slow it, cannot step off. The very thing that carries you forward is the same fixed motion that carries light across the universe, and it does not have a break. You are travelling at the speed of a light through time right now, and you will keep travelling at the speed of light through time for every second you are alive, and there is no pedal to lift, no way to hold still, no exit from the forward motion. The universe gave you one speed and one choice, how much of it to aim at space, and the rest goes to the future whether you like it or not. And this is the point where the unity of space and time stops being a fact about clocks on trains and becomes a fact about you. Space and time cannot be pulled apart, and the proof is running in your own body this instant, in the trade you make every time you move. You cannot cross a room without slowing your passage through time, because the motion for both comes out of the same fixed budget. You cannot separate your journey through space from your journey through time, because they are literally the same journey, the same fixed motion through the one fabric, merely pointed in different directions. When you walk, you're not moving through space and also, separately, moving through time. You're turning, in the four-dimensional world, tipping your single unchanging motion a few degrees away from the future and toward the door. Space and time are one thing because your motion through them is one motion. You have never done one without doing the other, and you never will, because there is only one thing to do, and it is called moving through space-time, and you are doing it at the speed of light as surely as any star. Now, I have been telling you extraordinary things, and I have been asking you to take a great deal on trust, following a chain of reasoning from a beam of light that would not change its speed all the way to the claim that you are, at this moment, racing through time at the speed of light. It would be fair at this point to want proof. It would be fair to ask whether any of this is more than a beautiful story told with confident words. So let me answer that, plainly and with numbers, because the astonishing thing about all of this is that it is not a story. It is measured. It is checked. It rains down through the roof above you. It flies around the planet in the bellies of ordinary aircraft, and it lives inside the small glowing rectangle you carry in your pocket, quietly correcting itself every second of every day. Let me show you the proof. Part 10. The proof falling through the roof. The first proof is falling through the ceiling above you right now, and it has been falling your entire life. It comes from tiny particles called muons, and their story is one of the cleanest demonstrations that time really does bend exactly the way Einstein said. A muon is a heavier cousin of the electron, and it is created high up in the atmosphere when cosmic rays, particles hurled at us from the sun and from distant exploding stars, slam into the top of the air and shatter. Muons are born in that collision, many kilometers above your head, and they come streaking downward at very nearly the speed of light. But muons are unstable. They fall apart, decay, in a tiny fraction of a second. Left to themselves, a muon lasts on average only about 2/millionths of a second before it disintegrates. And here is the problem. Even moving at almost the speed of light, 2/millionths of a second is not nearly enough time to travel all the way from the top of the atmosphere down to the ground. By every calculation that ignores relativity, almost every muon should decay high in the air, and only a tiny trickle should ever reach the surface. The overwhelming majority should never make it. But they do make it. They reach the ground in enormous numbers, far more than should be possible, and physicists measured exactly how many. In one careful experiment, researchers counted the muons arriving at the top of Mount Washington in New Hampshire, roughly 1,900 meters up, and found about 560 of them per hour, all moving at more than 99% of the speed of light. Then they took their detector down to sea level, near Cambridge, Massachusetts, to count how many survived the trip down. Without time dilation, with the muons clock running normally, only about 27 per hour should have lived long enough to arrive. Instead, they counted more than 400 per hour. 15 times as many muons survived as should have been possible, and the reason is time dilation, precisely as predicted. Think about what is happening from the muon's point of view, because it makes the unity of space and time vivid. The muon is moving so fast that its motion through time is slowed dramatically from our vantage point on the ground. Its internal clock, the little countdown to its own decay, is running many times slower than normal because it has spent almost its entire budget of motion on crossing space and has almost none left for time. So while a stationary muon lives 2/millionths of a second, this racing muon lives many times longer, by our clocks, easily long enough to reach the ground. Its journey through space bought it extra life by slowing its journey through time. The trade we described in your own body, the borrowing of time to pay for space, is written across the sky continuously, and its signature is the gentle rain of muons that reaches the ground and should not. Hold out your hand. Several of them are passing through it every second, each one a small piece of falling proof that time is not what Newton thought. The second proof did not fall from the sky. It was carried deliberately in the cabins of ordinary passenger planes, and it is one of my favourite experiments in all of physics because of how humble and direct it is. In the year 1971, two researchers named Joseph Hafeel and Richard Keating decided to test time dilation in the most literal way imaginable. They would take extremely precise atomic clocks accurate to billionths of a second, put them on commercial airline flights, fly them all the way around the world, and then bring them home and compare them against identical clocks that had stayed on the ground. If Einstein was right, the flying clocks, having moved through space, should come back having experienced slightly less time than the clocks that stayed put. The difference would be almost nothing, a matter of billionths of a second. But their clocks were good enough to catch even that. Let me put you in the room when the clocks came home, because it is a quiet and almost comic scene for something so profound. Two men carry 4 atomic clocks off a commercial airliner, clocks for which they had bought ordinary passenger seats, as if the instruments were tourists. They drive them to the United States Naval Observatory, where the reference clocks have been sitting still the whole time, ticking on solid ground. And now they set them side by side and read off the difference. Nobody in the room feels anything. Nobody could. There is no drama in the air, no shudder, no sign. There is only a set of numbers on a readout. The clocks that flew east, in the direction the Earth spins, have lost about 59 billionths of a second compared to the ground. The clocks that flew west against the spin have gained about 273 billionths. And those numbers, those almost invisible slivers of time, match the predictions of relativity to within the experiment's uncertainty. Time itself, caught in the act of bending, printed on a strip of paper in an ordinary office. The men check it twice. The universe is exactly as strange as the equations said. Now you might think that a difference of billionths of a second is the kind of thing that only matters to physicists with fancy clocks, a curiosity with no bearing on real life, and for most of history you would have been right. But there is a machine you use constantly, probably every day, that would fail completely within hours if engineers did not account for this exact effect, and it is sitting in your pocket. It is the network of satellites that lets your phone know where it is, the global positioning system. Here is how it works, and why relativity is baked into it. Each of those satellites carries an atomic clock, and your phone figures out its location by comparing the timing signals from several satellites at once, using the tiny differences in when each signal arrives to triangulate your position. This only works if the satellite clocks and your phone agree on time with extraordinary precision, down to billionths of a second, because light and radio travel so fast that even a tiny timing error becomes a large error in distance. And those satellites are in 2 different relativistic situations at once. They are moving fast, orbiting the Earth at several kilometers per second, which by time dilation makes their clocks run slow. But they are also high up, about 20,000 kilometers above the surface, where the pull of Earth's gravity is weaker, and that, through a second effect from Einstein's later theory, makes their clocks run fast. The 2 effects do not cancel. Added together, a satellite clock gains about 38 millionths of a second every single day compared to a clock on the ground. 38 millionths of a second sounds like nothing. But remember how fast the signals travel. If you let that error accumulate uncorrected, your position as reported by the satellites would drift by about 10 kilometers every day. Within a single afternoon, the map on your phone would place you in the wrong part of the city. Within a few days, it would be useless. The only reason it works at all, the only reason the little blue dot lands on the right street, is that the engineers who built the system wrote Einstein's mathematics directly into it, deliberately setting the satellite clocks to tick at a rate that looks wrong on the ground so that they will run correctly once they are in orbit and moving. Every time you find yourself on a map, you are trusting to the nanosecond that time runs differently for a moving satellite than it does for you. You're using the unity of space and time as a tool, whether you know it or not. There is a third proof, and it runs quietly in laboratories every day. In the great particle accelerators, physicists take tiny particles and whip them up to more than 99.9% of the speed of light, around and around enormous rings. Many of these particles, like the muons in the sky, are unstable and should fall apart almost instantly. But moving so close to light speed, their internal clocks slow so severely that they survive hundreds of times longer than they otherwise would, circling the ring again and again, living on borrowed time bought with speed. The engineers who design these machines cannot make them work at all without accounting for this. Time dilation is not a subtle correction they apply for a little extra accuracy. It is a dominant, unavoidable fact of daily operation, as ordinary to them as friction is to a mechanic. The strangeness we have been describing is, For the people who work at the edge of physics, simply the water they swim in. And there is a fourth proof, and it is you. Every one of these experiments, the muons and the flying clocks and the accelerated particles and the satellites overhead, is only confirming what your own existence already demonstrates. You're made of particles moving at various speeds, each one carrying its own tiny clock, each one trading time for space exactly as the theory says. The unity of space and time is not a fact about distant laboratories. It is the operating principle of every atom in your body, running silently and ceaselessly, whether or not anyone is there to measure it. The universe does not save its strangeness for special occasions. It is strange all the way down, all the time in you. So this is not philosophy. This is not a clever story. The slowing of moving clocks has been measured in particles falling through the sky, in atomic clocks flown around the planet, in the satellites that guide your daily life. The fabric is real. The trade between space and time is real. It is engineered into the infrastructure of the modern world, checked billions of times a day, and it has never once come out on the side of Newton. And once you accept that the fabric is that real, that solid, that reliable, a natural question follows. If space-time is a real thing, a genuine fabric and not just a bookkeeping trick, then can it do the things a fabric does? Can it stretch? Can it sag? Can it ripple? The answer, it turns out, is yes, and following it leads straight to gravity itself. Part 11. The fabric that bends. Everything we have said so far comes from Einstein's first great theory, the one he published in 1905, which describes how space and time behave for observers moving steadily in straight lines. But Einstein was not finished. For the next 10 years he wrestled with a harder question, and when he emerged in 1915, he had shown that the fabric of space-time is not merely a fixed backdrop that everyone slices differently. It is a physical thing that can bend, and its bending is something you have felt every day of your life. You call it gravity. I am not going to unfold the whole of that second theory here, because the mechanism of gravity is its own long story, and we have followed it on other nights. But I want you to see how naturally it grows out of everything we have built, because it is the final confirmation that space-time is real. Einstein's insight was that matter and energy, anything with mass, bends the fabric of space-time around it, the way a heavy weight set on a stretched sheet makes a dip. And objects moving nearby, following the straightest possible path they can through that curved fabric, get deflected toward the mass, not because a force reaches out and pulls them, but because the fabric they are travelling through is no longer flat. The Earth holds you to the ground not by tugging on you, but by curving the space-time around it so that the straight path forward in time, the path you naturally follow, bends toward the planet. Falling is just moving straight ahead through a fabric that has been warped. Notice what this does to the story of space and time. We already knew they were one fabric, woven together, sliced differently by different observers. Now we learn that this single fabric is not rigid and eternal, but flexible and responsive, that it sags under mass and springs under motion, that it is a participant in the universe rather than a stage the universe sits on. Space and time are not just united. Together, as space-time, they are a physical medium with a shape, and that shape can change, and the changing of that shape is the most familiar force you know. And if space-time is a genuine, flexible fabric, then it should be able to do the one thing every fabric does when you disturb it sharply. It should be able to ripple, snap a bedsheet and a wave runs across it, strike the surface of a pond and rings spread outward. Einstein predicted that if you could shake space-time violently enough, waves would spread through it too, ripples in the fabric of the universe itself, carrying the news of the disturbance outward at the speed of light. For a century this remained only a prediction, because the effect is so faint that catching it seemed hopeless. The ripples from even the most violent events in the cosmos arrive here almost infinitely smoothed out, stretching and squeezing space by less than the width of an atomic nucleus. And then, in the year 2015, we caught one. 2 black holes, each around 30 times the mass of the Sun, had spiraled into each other more than 1 billion light-years away, and in the final instant of their collision, they shook space-time so hard that the ripple was still detectable when it washed over the Earth after its long journey. An instrument built for exactly this purpose felt the fabric of space stretch and relax by an amount almost too small to name, a fraction of the width of a proton across a detector kilometers long, and it matched Einstein's prediction with remarkable precision. Let me say that plainly. We felt the fabric of the universe move, the same space-time whose slicing gives us space and time, whose turning slows our clocks, whose curving holds us to the earth, rang like a struck bell, and we heard it. There is no longer any room to think of space-time as a convenient fiction, or a way of speaking. It is as real as water, and it wobbles. So we have arrived somewhere solid. Space and time are one fabric. The fabric is real. It can be turned, and turning it trades space for time. It can be curved, and its curvature is gravity. It can be shaken, and its shaking spreads as waves we have now touched. Every step of this is measured, checked, built into our technology, confirmed to absurd precision. On the level of physics, the case is closed. Space and time cannot be pulled apart, and we know it as surely as we know anything. But there is one more room to walk into, and it is the strangest of all, because it is where the physics stops being about clocks and satellites and starts being about you, about the shape of a human life, about whether the moment you're living in right now is passing away forever or standing still and permanent in a fabric that holds all moments at once. If space and time are truly one four-dimensional thing, laid out together, then a very old and very unsettling question rises up, one that Einstein himself faced near the end of his life, in a letter he wrote to console a grieving family. It is the question of whether the flow of time, the passing of one moment into the next, the whole felt current of your existence is even real. Let me take you into that question gently, because it is the one that stays with you after the numbers fade. Part 12. The stubbornly persistent illusion. Here is the question that has been waiting for us since the beginning, and now we're finally ready to face it. If space and time are truly one fabric, laid out together in 4 dimensions, then what happens to the flow of time? What happens to the feeling, the absolute certainty, that this moment is here and then gone, that the past is over and the future has not yet arrived, that you are perched on the thin moving edge of now, watching moments come into being and pass away? Let me build the picture carefully, because it follows from things we have already established, and it is going to lead somewhere that touches everything you are. We saw, back at the beginning, that there is no universal now, that different observers slice the present at different angles, and that all their slices are equally valid. Sit with what that implies. If my now and your now cut through the fabric at slightly different angles, then an event that lies in my future can lie in your present, and an event in your present can lie in someone else's past. The same event is future for one observer, present for another, past for a third, and none of them is wrong. But if an event is genuinely, definitely happening in someone's present, then in some real sense it must exist. And if events that are still in my future are right now real and present for someone else moving differently, then those future events must already exist too, laid out in the fabric, as real as this moment, simply at a different location in time. Follow that all the way down and you arrive at one of the most staggering ideas in all of physics. It is called the block universe. In this picture, the whole of space-time, all of it, past and present and future together, exists as a single, finished, 4-dimensional structure. Not a stage on which history unfolds moment by moment, but a completed thing, laid out whole, with every event that has ever happened or ever will happen, sitting permanently at its own place in the fabric. Your birth is there at its location. This moment is there at its location. Your death is there at its location. And your 100th birthday, if you have one, is there too. No more and no less real than today. Nothing comes into being. Nothing passes away. It all simply is, the way a whole loaf of bread simply is, with every slice already present, whether or not anyone has cut it yet. There is a way to feel how hard this conclusion is to escape, once you have accepted relativity. Go back to the 2 lightning strikes and the train. We saw that whether 2 separated events happen at the same time depends on your motion, that your now and another observer's now cut through the fabric at slightly different angles. Now push that idea outward, across a great distance. Somewhere far across space, there are events that lie in your present, according to how you happen to be moving, and among them are events that, for a person walking slowly past you in the other direction, lie in the future. If those events are genuinely present for you, and genuinely still to come for them, and neither of you is wrong, then the future for one observer is already, definitely, part of the present for another. And the future cannot be an empty nothing waiting to be created if it is, at the same moment, somebody else's solid present. It has to already be there, laid out in the fabric, or the disagreement between the two of you would have no consistent answer at all. Relativity does not merely allow the block universe as one option among many. It seems to press it upon us the moment we take the personal nature of the present seriously and refuse to crown our own now as the one true now for all the cosmos. In this view, the flow of time, the sense that moments are being created and destroyed, that now is moving forward through the past toward the future, is not a feature of the universe at all. It is something added by minds like ours. The universe does not flow. It just is, spread out in 4 dimensions, still and complete. And the powerful, undeniable feeling you have that time is passing, that you're being carried forward, that the present is special and moving, is, in this reading, a kind of illusion, a story your consciousness tells as it experiences one slice of the fabric after another, mistaking the order of its own experiences for a movement of the universe itself. I want to be honest and say that not every physicist accepts this. There are serious thinkers who resist the block universe, who argue that the present really is special, that the future really is open and not yet written, that relativity has been pushed too far when it is used to freeze all of time into a finished object. This is a genuine, unsettled debate, one of the places where physics shades into the hardest questions in philosophy, and it connects to another mystery we have not solved, the puzzle of why time seems to have a direction at all, why we remember the past and not the future. So I am not going to tell you that the block universe is certainly true. I am going to tell you that it follows naturally from taking the unity of space and time seriously, and that the man who gave us that unity seemed at the end to believe it. Let me take you to the moment he said so, because it is one of the quietest and most human scenes in the history of science. It is the spring of 1955. Albert Einstein is an old man now, in the final weeks of his own life, though he may not fully know it. His oldest and dearest friend, Michel Besso, the man he had talked physics with as a young clerk in Bern, the one person who had been with him near the very beginning, has just died. And Einstein sits down to write to Besso's family, to offer them what comfort he can. He does not offer them the usual words. He offers them his physics. He writes that Besso has departed from this strange world a little ahead of him, and then he writes the line that people have carried ever since. That signifies nothing, he says. For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. Picture him at the desk, pen in hand, the most famous mind of his age, consoling a grieving family not with heaven, not with memory, but with the structure of space-time itself, telling them, gently, that in the truest reading of his own theory, their father has not truly gone anywhere. He simply exists permanently at his own place in the fabric, in a stretch of time we happen to have moved past. Weeks later, Einstein himself would die and go to his own fixed place in the same fabric. Now let me bring back a word we met in that lecture hall in Cologne, because it returns here transformed. Minkowski told the world that space by itself and time by itself were doomed to fade away into mere shadows, that only their union was real. When he said it, he meant something about geometry, about how the measurements of moving observers are projections of one underlying object. But listen to that word now, at the end, and it means something far more intimate. If the block universe is right, then past, present, and future are themselves the shadows, 3 shadows cast by one 4-dimensional fabric, and the moments of your life, which feel so vividly like they are arriving and departing, are simply the places where you happen to be standing as the light falls. The shadows that are doomed to fade are the very moments you are living. And the thing that does not fade, the pencil behind the shadows, is the whole of your existence laid out complete, every moment you have loved and every person you have lost still there, at their own address, unreachable but not erased. Whether that is the most comforting thing you have ever heard or the most frightening, I honestly cannot tell you. I have sat with it many nights, and it has been both. And now, at last, we can return to the sentence I gave you at the very beginning, the one that sounded like a mistake. Space equals time. We have spent this whole walk earning the right to look at it clearly, and here is the honest truth about it. Space and time are one fabric, yes, woven together so completely that no observer can pull them apart, traded back and forth by every motion, sliced differently by every now. In almost every way they are the same kind of thing, 2 directions in one 4-dimensional world. but not quite. There is that single small difference I asked you to remember, the one quiet minus sign in the rule for the space-time interval, where time enters with the opposite sign to space. That one sign is the whole difference between them. It is why you can walk back to where you started in space but never walk back to a moment in time. It is why the fabric has a grain to it, a direction, a distinction between the way that leads to the past and the way that leads to the future. Space and time are one, but that single sign keeps them from being identical, and everything that makes your life a life, the memory behind you and the mystery ahead of you, the fact that you were born before you will die and can never reverse it, lives inside that one small mark. Space almost equals time. The distance between almost and exactly is the shape of a human life. So the thumbnail was not lying to you, and it was not quite telling you the truth either. It was pointing at the door. Behind the door is a universe where space and time are a single thing, and a single sign that keeps that single thing from swallowing you whole. And that leaves us with one final question, the one we still cannot answer, the one that waits at the bottom of everything. Let me take you to it, and then let you rest. Part 13. What the fabric is made of. We have come a long way, from a beam of light that would not change its speed to the discovery that you are moving through time at that same speed right now, and along the way we have watched space and time dissolve into a single fabric that cannot be pulled apart. It would be a fine place to stop, with everything measured and confirmed and settled. But I would be leaving out the most honest part if I did, because for all that we know about this fabric, there is something enormous we do not know, and it sits underneath everything we have said tonight. We do not know what space-time is made of. Consider how strange that is. We have measured the fabric's behavior to staggering precision. We can tell you exactly how it slices, exactly how it turns, exactly how it curves under a mass and ripples when black holes collide. We have built its rules into the satellites over your head and the particles falling through your ceiling. We understand the geometry of space-time better than we understand almost anything in nature. And yet, if you ask the simplest possible question, what is it? What is this fabric actually made of? What is the stuff that space and time are two aspects of? We fall silent. We have described the union of space and time in exquisite detail, without ever being able to say what has been united. There are hints that the fabric may not be fundamental at all, that space-time itself might be built out of something more basic, the way a smooth-flowing river is really made of countless separate water molecules, or the way a solid table is really mostly empty space with tiny particles held in a lattice. When physicists try to combine the fabric of space-time with the strange rules of the quantum world, the mathematics suggests that at almost inconceivably small scales, far smaller than an atom, far smaller than the particles inside an atom, down at a size so tiny it would take a number with 35 zeros to describe how many of them fit in a meter, the smooth fabric may break down. Down there, at what is called the Planck scale, space and time as we know them may lose their meaning entirely, dissolving into some more basic structure that we do not yet understand and cannot yet observe. In some of these ideas, space-time emerges from the way distant things are quantum mechanically linked to one another, so that the fabric of the universe is woven, quite literally, out of the connections between its parts. In others, space is built from tiny discrete pieces, a fine grain beneath the smoothness. Nobody knows which, if any, is right. We united space and time more than a century ago, and we still cannot say what the union is made of. It is the single greatest unsolved problem in physics, and it is hiding inside the most ordinary moment you will ever live. Because here is where all of this comes home. Raise your hand one more time, slowly, the way you did near the middle of our walk, and then let it come to rest. That small motion was not what you always thought it was. Your hand did not simply move through space while time ticked along separately in the background. Your hand carved a path through the single four-dimensional fabric of the universe, a path that runs through space and through time together, inseparably, a line drawn across space-time that begins earlier tonight and ends now, at rest. And that path is not a passing thing that vanishes once the motion is over. It is there, in the fabric, at its place, a permanent feature of the four-dimensional world, the way a road is still a road even when you have driven off the end of it. The moment you just lived is not gone. It is behind you in the fabric, fixed, real, exactly where it happened, and you're already somewhere new, carving the next stretch of the only path you will ever draw, and you cannot stop drawing it. Remember what we learned in the middle of the night, the thing that changes the meaning of stillness. You have never been still. Even now, as you lie there, as quiet and motionless as you can make yourself, ready to let this end and let sleep come, you're not still at all. You're moving through the fabric at the speed of light, pouring almost all of that motion into the pure forward direction of time, carried toward tomorrow at the greatest speed the universe permits. You could not hold still if you tried. There is no still to hold. The same motion that carries light across 1 billion years is carrying you, gently, into the next moment and the next, and it will not stop. And you would not really want it to, because that motion is simply what it is to be alive inside a universe made of one fabric. So let the old picture go, the one you started the night with, the picture of space over here and time over there, two separate things minding their own business. It served us well for 200 years, and it was never quite true. There is only the one fabric, and you are woven into it, and every step you have ever taken and every second you have ever felt were the same motion through the same four-dimensional thing, pointed in slightly different directions. Space and time were never two. They were always one, and you were always moving through all of it at once, at the speed of light, whether you were running or sitting perfectly still. There is something restful in that, once the strangeness settles. You do not have to hold the universe's clock. There is no universal clock to hold. You do not have to keep the present moment from slipping away. In the fabric, no moment slips away at all. Every moment you have lived is still there, at its own place, as real as this one, and the moment you are in right now is already, permanently, part of the four-dimensional shape of everything. You're not standing on a thin moving edge above an abyss where the past falls away into nothing. You are woven into a fabric that keeps every thread, and the sense that time is running out is, if Einstein was right, only a stubbornly persistent illusion, a shadow cast by the particular way a mind moves through a world that, underneath, holds still and whole. You do not have to settle any of this tonight. The physicists have not settled it either, and they have had a century to try. You can simply let the two pictures rest side by side in the dark, the one you were born with and the one we have uncovered, and notice that both of them, in their own way, are gentle. In the picture you were born with, this moment is precious because it is fleeting, here and then gone, and that is a kind of beauty. In the picture we have found, this moment is precious because it can never truly be lost, fixed forever at its own place in the fabric, and that is a kind of beauty too. Neither picture takes anything from you. Neither one changes the quiet of the room around you, or the weight of your own body settling towards sleep. Whether time flows or only seems to, you are here, now, woven into the same fabric as every star, carried forward at the speed of light by a universe that has never once let go of anything it has made. We do not know what the fabric is made of. We may not know for a long time, but we know that you are part of it, that space and time cannot be pulled apart because they were never two, and that the simple fact of being here, now, moving forward, sits on top of the single greatest mystery there is. You are made of that mystery. You move through it every second, and tonight at least you can stop trying to move through it and let it carry you at the speed of light, gently, into the dark, where it has been taking you all along.